Here we have a vector valued function r. Its cross product with its differential dr vector is equals to 0. Then we have to show that r cap, the unit vector, r is a constant. So let us begin. We first begin with the differential dr vector. And we know that r vector is given by, we'll take the magnitude where r represents the magnitude of vector r and multiply to its unit vector along the direction of r. So that means dr vector is simply d r cap. Now we'll have to use the definition, that d of xy, so that's equals to x dy plus y dx. So that means the differential r cap will be r dr cap plus r cap dr. So this is our dr vector. Now we'll take the cross product with vector r. So we have r cross with dr vector. So that would mean we'll take the vector r and cross it with dr vector, which is r dr cap plus r cap dr. So let's multiply it. So here r is simply a scalar. So we have r multiplied to r vector crossed with dr cap plus r vector will get crossed with r cap, because we can only take the cross product between two vectors. Dr is a scalar. Then r vector and r cap both are in the same direction. So that's mean by definition this will go to 0. Next we have r vector. So here we can again replace r vector with r times r cap. So we have r cap crossed with dr cap. So that means this is equals to r squared times r cap crossed dr cap. So vector r, when we crossed it with its differential element dr vector, so that will be equals to r squared multiplied to r cap cross dr cap. Now here we will suppose that r vector cross dr vector is equals to 0. So that means this will be equals to 0. So we have r squared r cap cross dr cap equals to 0. Here r equals to 0 is a trivial condition. So we'll only consider r cap crossed dr cap, that is equals to 0. So let's label this as equation number 1. So we will use it. We'll come back to this a moment. So we have to show that the unit vector r cap is a constant. Now if we suppose that, we have to show it, but if we suppose that r cap is a constant, then it means that if we take r cap and dot it with its differential, that is dr cap, then this must be equals to 0. So this is a property where r cap is a constant unit vector. Now let's call it condition 2. Now from 1 and 2 we have the unit vector r. When we cross with dr cap, that's equals to 0. So this would mean that r cap, this would mean two things. This could mean r cap and dr cap, they are in the same direction, that's why it's equals to 0. Or it could mean either of r cap or dr cap is 0. And here r cap dotted with dr cap is 0. That would mean that our unit vector is perpendicular to dr cap. So this is 1, or the other would be either of them is 0. So if we combine 1 and 2, the only way this could be true is when dr cap is equals to 0. And if dr cap is 0, that means that r cap must be a constant. So we have shown that when r vector crossed with its differential dr vector is equals to 0, thus this implies that r cap must be a constant. Okay. So this proves the question. However, there is an alternative way. If you are not satisfied with this particular way, let's try that out as well. So we will suppose that r vector r is defined by x I cap plus y j cap plus z k cap. So this would mean that its differential dr vector, that will be dx I cap plus dy j cap plus dz k cap. Now we'll take the cross product between the vector r and dr vector. So let's consider the 3 by 3 determinant in the first row, we have the unit vectors I, j, and k. In the second row, we have the components of the vector corresponding to our vector. So that will be x, y, and z. And in the third row, we have components of dr vector. So that's dx, dy, dz. So if we expand it along the first row, so we will have I cap y dz minus z dy minus j cap times x dz minus z dx plus k cap times x dy minus y dx. Right. So here we are given that r vector crossed with dr vector, that's equals to 0. If this is equals to 0, that means the components must be also equals to 0. So we have y dz minus z dy, that's equals to 0. We have x dz minus z dx, that is equals to 0. And x dy minus y dx, so that is also equals to 0. So this simply means that we have dx over x equals to dy over y, which is equals to dz over z. But now if we consider if dx over x is equals to dy over y and solve this, that means we will integrate both sides. So we have dx over x is equals to integration dy over y. So integration of dx over x, so that's natural log of x, equals to integration of dy over y, so that's natural log of y, plus the constant of integration, let's call it natural log of c1. So if we get rid of the logarithm using the properties of logarithm, we should get x equals to y times c1. And we're going to solve the other differential equation. Dy over y is equals to dz over z. So using the same methodology, we will get y is equals to z times c2. Fine. So that means we started out with r vector, which is x I cap plus y j cap plus z k cap. So that means x will be replaced with y c1. So we have y times c1 I cap plus y j cap plus z is, so here we can also rewrite it as z is equals to y over c2, or let's call it y c3, where c3 is equals to 1 over c2. Right. So z will becomes y times c3. The only reason we are doing is so that we can take y as the common factor. So we have c1 I cap plus j cap plus c, this will be c3 k cap. So there is a k cap that I've missed. So this is our vector r. Now let's find out the unit vector r cap. So our unit vector is defined as vector r divided by the magnitude of vector r. So we'll need to obtain the magnitude of vector r. So that will be simply equals to, so we have y squared, this will be multiplied to c1 squared plus 1 squared plus c3 squared, or simply y times c1 squared plus c3 squared plus 1. We will substitute the value. So we have y times c1 I cap plus j cap plus c3 k cap whole divided by y times and c1 squared plus c3 squared plus 1. So the y and y cancels out, and we're left with r cap is equals to c1 I cap plus j cap plus c3 k cap. So this entire thing is divided by square root of c1 squared plus c3 squared plus 1. And since c1, c3 are constant, we say that this is a constant unit vector. So we have shown that our unit vector r cap is a constant given the condition that r vector crossed with the r vector is equals to 0.